UR Studio Roofs Training. Roofs: framing, sheathing, flashing, roofing, gutters and downspouts, insulation and ventilation. What is a roof? The roof is the part of a wood frame structure that varies most widely across the country. This is because the roof plays the most active role in all the parts of a building in protecting against the weather. And in the US, variations in the weather are extreme. Some roofs protect primarily against the heat of the sun, others must shelter the inhabitants under tons of snow. Selection of a roof slope. One of the most obvious variations of roof form has to do with the slope or pitch of the roof. The main factors affecting the slope of a roof are stylistic considerations, the type of roofing material to be used, and the space desired beneath the roof. The climate also has a strong influence on roof slope. Areas of significant rainfall have roofs pitched to shed the rain. Warm, arid climates tend to favor flatter roofs. Selection of roof slope. The slope or pitch of a roof is measured as a proportion of rise to run. A roof that rises 4 inches in 1 foot, 12 inches, is said to have a 4-inch 12 pitch, or 412. The second number in the roof pitch proportion is always 12. Take a look at this detailed illustration. The shape of roofs. Roof shapes tend to have a regional character that reflects not only climatic variations, but also historical and material influences. All roof forms are derived from 4 basic roof shapes shown below: the flat roof, the shed roof, the gable roof, and the hip roof. The shape of roofs. Virtually any roof form may be made by combining the 4 basic shapes with the connections illustrated in this chapter. Some of these composite shapes are so common they have their own names. For example, the hip and gable shapes can combine to form a Dutch gable. 2 different slopes of gable roof can combine to form a gambrel roof. A shed dormer may be added to a gable roof, and so forth. 4 common combinations are shown above. What type of construction system? Roofs are constructed either with rafters, sticked frame roofs, or trusses. Sticked frame roofs are usually made with dimension lumber but may also use composite materials such as plywood eye rafters, which are simply plywood eye joists. Stick framing originated before the development of wood frame construction in the 19th century. Antecedents of the modern stick frame roof can be seen on ancient roofs around the world. And modern stick frame roofing remains popular because it is the most flexible roof framing system and the materials are least expensive. Trusses are made of a number of small members, usually 2x4s, joined in a factory or shop to make one long structural assembly. Only in very simple buildings does the labor savings of a truss system compete with stick framing. 2 types of construction system: stick framing, truss framing. Stick framing construction system. Stick framing. One advantage to stick framing is that the space within the roof structure can become living space or storage. Vaulted, cathedral ceilings, half-story living spaces on upper floors, and true storage attics are all examples. A second advantage is that complex roofs may be stick-framed more economically than truss-framed. For this reason, stick framing may be attractive to owner-builders when the cost of labor is not a factor. Truss framing construction system. Truss framing. Trusses can span much farther than stick-framed roofs, leaving large open areas below them or permitting partial walls to be relocated without consideration for the roof structure above. Trusses go up quickly, usually resulting in a cost saving over stick-frame roofs on simply shaped buildings. A big disadvantage of trusses is that the truss roof is almost impossible to remodel, since trusses should never be cut. Roof framing. Rafters are usually 2x6, 2x8, 2x10, or 2x12. And spacing is usually 16 inches or 24 inches. On-center species vary from region to region. Rafter sizing depends primarily on span, spacing, roof loads, and sometimes on required insulation depth. Stick framing. Stick frame rafters may be supported by the walls of the building, by a structural ridge beam, or by purlins. Simple span roof. The simplest sloped roof, the shed roof, has rafters that span from one wall to another. These rafters must be strong enough to carry the dead load weight of the roof itself and subsequent layers of re-roofing, plus the live load weight of snow. The rafters must usually be deep enough to contain adequate insulation. Triangulated roof. Common full-length rafters are paired and usually joined to a ridge board. Each rafter spans only half the distance between the two walls. Horizontal ties, either ceiling joists or collar ties, form a triangle with the rafters. Ceiling joists are generally located on the top plate of the walls but may also be located higher to form a partially vaulted ceiling. Collar ties are usually nailed near the top of the roof between opposing rafters and spaced at 4 feet on center. Collar ties are not sufficient by themselves to resist the outward thrust of the rafters. Rafters in triangulated roofs are shallower than those in shed roofs of equal width because they span only half the distance of the shed rafters and because they do not usually contain insulation. Structural ridge beam. The horizontal ties that are required in a triangulated roof may be avoided if the rafters are attached at the ridge to a structural ridge beam or wall, which effectively changes the triangulated roof into 2 simple span roofs. Purlin. A horizontal member that supports several rafters, usually at mid-span. Purlins were commonly used to help support the long, slender rafters of pioneer houses and barns. Today, they are also used occasionally to reduce the span of a set of rafters, but the purlins must themselves be supported by the frame of the structure. Note, the name purlin is also given to a member that spans across rafters to support roof decking. Ceiling joist. Ceiling joists are very similar to floor joists. In fact, the second floor joists of a 2-story building act as the ceiling joists for the story below. Ceiling joists are distinguished from floor joists only when there is no floor, except an attic floor, above the joists. Ceiling joists are sized like floor joists. The span of the joist depends on spacing and whether the attic above the joist will be used for storage. Types of roof framing. Valley framing, hip framing, flat roof framing. Valley framing. The inside corner of 2 intersecting roof planes is called a valley. 3 types of valley framing. Valley rafters supported by ridge, valley rafters supported by header, farmer's valley. Valley rafters supported by ridge. Valleys are supported by a valley rafter that extends from the outside wall of the building to the ridge or to a header. These valley rafters support large loads and should be engineered. Jack rafters support the area between the valley rafter and the ridge or header. Valley rafters supported by header. Valley rafters can be supported at the top by a ridge or by a header. The ridge support system is more practical when the ridges of the intersecting roofs are close together. The header support system is better when the lower ridge intersects with the main roof near or below the center of the rafter span. Farmer's valley. Where headroom is not required between intersecting roofs, a farmer's valley or California valley may be constructed. This valley is made without a valley rafter. One roof is first built entirely of common rafters without any special valley framing. Then 2x-sleepers are installed over the rafters or over the sheathing of the first roof, and jack rafters are attached to the sleepers. Hip framing. A hip is the outside corner where 2 planes of a roof meet. It is comprised of a hip rafter at the corner and jack rafters from the hip to the eave. The hip rafter is supported at its lower end by the wall at plate level or by a post and at its upper end by the ridge or by a wall. Flat roof framing. The framing of a flat roof is more like a floor than it is like a pitched roof. The joists are level or nearly level and support the ceiling below and the line loads above. Connections to walls are like those for floors. As for floors, the structure of a flat roof may be a joist system, dimensional lumber or laminated, a girder system, or a truss system. Blocking and bridging must be considered at the appropriate locations. Flat roof framing. Flat roofs are unlike floors, however, in that they are not really flat. They might be more properly called low-slope roofs because they must slope at least 14 inches per foot in order to eliminate standing water. Eaves and rakes. Designing the basic shape of a roof and designing the configuration of eaves and rakes are the most critical task in roof design. Stylistically, the selection of eave and rake types should complement both the roof form and the roofing material. Functionally, the eave and rake should help protect the building from the elements. The shape of the roof will suggest certain eave or rake shapes, and certain eave types work best with particular rake types. Eaves and rakes. Eave. The eave is the level connection between the roof and the wall. Eaves are common to all slope roofs and often to flat roofs. Rake. The rake is the slope connection between the roof and the wall. Only shed and gable roof types and their derivatives have a rake. 4 basic types of eave: exposed eave, soffitted eave, abbreviated eave, boxed-in eave. Exposed eave goes with shed, gable, hip roofs equally well. Soffitted eave works best on hip or flat roofs with no rake, also used on gable roofs as well. Abbreviated eave goes well with shed, gable, hip roofs equally well. Boxed-in eave goes with shed, gable, hip roofs equally well. 3 basic types of rakes: exposed rake, boxed-in rake, abbreviated rake. Exposed rake. Take a look at this detailed illustration. Boxed-in rake. Reference this detailed illustration. Abbreviated rake. Take a look at this detailed illustration. Plywood eye rafters. The lightweight, strength, precision manufacturing, and the long lengths that make structural plywood and other composite framing materials appropriate for floors. Eye rafters are generally stiffer and stronger and can span farther than dimensional lumber rafters of the same size. But they can also cost more, and their appearance is not satisfactory if exposed. Plywood eye rafters can be attached to each other and to other members with metal straps and hangers, and can be cut on site. They do not have as much strength and compression as lumber rafters and must therefore be stiffened at joints and at other conditions required by manufacturer specifications and local codes. Plywood eye rafters. Take a look at this detailed illustration. Roof trusses. Roof trusses, like floor trusses, are a framework of small members, usually 2x4s, that are connected so that they act like a single large member. 5 types of common roof truss: king post truss, scissor truss, mono-pitch truss, Fink truss, parallel cord truss. King post truss. The simplest truss, which can span about 25 feet. Please reference this detailed illustration. Scissor truss. The sloping bottom cords of scissor trusses can increase interior volume. Spans up to 40 feet are possible. Please reference this detailed illustration. Mono-pitch truss. A mono-pitch truss for shed roof buildings spans about 25 feet. Fink truss. Spans over 40 feet. Parallel cord truss. Parallel cord trusses are for flat roofs. Standard spans are available up to 30 feet. Roof sheathing. Roof sheathing attaches to the surface of the rafters or trusses to form the structural skin of the roof. It spans the rafters to support the roofing, and in the case of panel sheathing such as plywood, acts with the wall to resist horizontal loads. Roof sheathing material must be coordinated with the roofing itself, since each type of roofing has special requirements. 2 basic types of sheathing: solid sheathing, open sheathing, skip sheathing. Solid sheathing. Solid sheathing provides a continuous surface at the plane of the roof. This type of sheathing is necessary for composite roofing and built-up roofing, which have no structural capacity themselves. Metal, tile, and shingle roofing may also be applied to solid sheathing. Open sheathing. Open sheathing, also called skip sheathing, is composed of boards spaced apart. This type of roof sheathing is used under wood shingles and shakes, which usually require ventilation on both sides of the roofing material. Open sheathing may also be chosen for economic reasons, but only if used with roofing systems such as metal and tile, which have the structural capacity to span between sheathing boards. Solid roof sheathing. Plywood and non-veneered panels. Panel installation. Low cost and ease of installation make plywood and non-veneered composite panels the sheathing of choice for most modern roofs. The system provides a structural diaphragm and is appropriate for all but wood and shake roofing, which requires ventilation. The standard panel size is 4 foot by 8 foot, so rafter or truss spacing that falls on these modules is most practical. Care must be taken to protect panel edges from the weather by the use of trim or edge flashing. Sheathing at exposed overhangs must be exterior or exposure 1 rated panels and must be thick enough to hold a nail or other roof fastener without penetration of the exposed underside. Solid roof sheathing, exposed T&G decking. T&G sheathing, decking, is also used for exposed ceiling applications. It can be used selectively at exposed eaves or overhanging rakes. Rafters are spaced at wide centers since the decking will span more than 24 inches in most cases. Since the sheathing material does not provide a diaphragm at the plane of the roof, other means of bracing the roof against horizontal loads must be employed. For example, the roof may be braced with metal straps applied to the top of the sheathing or with a thin layer of plywood. Insulation for an exposed ceiling must be located above the sheathing. Insulation will vary with climate and with roofing material. Rigid insulation is usually the most practical because of its thin profile, but is more expensive than batt insulation. Batts are often chosen for colder climates, where the thickness of either type of insulation, rigid or batts, requires adding a second level of structure above the decking to support the roof. Metal or composition roof. Metal or composition roofing may be applied directly over rigid insulation on T&G sheathing. For this construction, fasteners must be sized to penetrate through the insulation but not through the decking. Roofs summarizing: framing, sheathing, flashing, roofing, gutters and downspouts, insulation and ventilation.